All right, so on your Smart Prep notes, I'm busy on page 2. So that's where you will find this. And all that we're going to do is we're going to talk about the 2 different types of number patterns that you are going to work with in grade 11, and that is linear and quadratic. And we're going to do an example of each. Okay, so linear number pattern, you should know this very well, is a pattern where there is a constant first difference. So if we have a look at the example that they give you on page 2, when we say that there is a constant first difference, it means if you say 7 minus 2, let's just get my pen working here. There we go. If we say 7 minus 2, we get 5. 12 minus 7 is 5. 17 minus 2 is 5. And so the difference every time is constant. The formula that we use for a linear pattern is Tn equals Dn plus C. Some people will say Bn plus C or An plus C. That doesn't really matter. What you do need to understand is the D stands for your first difference. And the C, I will normally get that by inspection. Okay, your teacher may have another method to get C, that's fine, but I prefer to just use inspection. Okay, so let's take a look at this example, very basic example. If we want Tn, well, we would say, okay, our constant difference every time, so Dn plus C, our constant difference every time is 5, so 5n. Now, I say to myself, okay, if I look at my first term, then n is 1. So if I look at my first term, n is 1. So I say 5 times 1 is 5. However, my first term is not 5. My first term is 2. So how do I go from 5 to 2? I subtract 3. Then I check it again. I say, okay, if I look at my second term, 5 times 2 is 10. But I want an answer of 7, so I have to subtract 3. Or 5 times 3 is 15, but I want 12, so I have to subtract 3. So that is then the formula for our linear pattern. Tn equals 5n minus 3. And the second part to that question asks, determine the 100th term. So we will say Tn is 5n minus 3. And we now want the 100th term. So we will say 5 times 100 minus 3. And 500 minus 3 is 497. So that is it for linear patterns. Okay, 2 most important things you have to remember for linear patterns is constant first difference and Dn plus C is your formula. All right, something I didn't say at the beginning, but I think you know this well. Please use the chat or unmute yourself if you've got any questions you'd like to ask. If you've got any of the questions you'd like to answer, please get involved like that. All right, any questions you'd like to ask about this first example that we've gone through of a linear number pattern? Fantastic. I'm glad to not hear anything because that means you are all happy with linear number patterns. The second example I would like us to take a look at is the idea of a quadratic number pattern. Now, there are 2 things that you need to remember for a quadratic number pattern, and we are still on page 2 of the Smart Prep notes, is with the quadratic number pattern, there is a constant second difference. So a quadratic number pattern has a constant second difference, and its general formula is an squared plus bn plus c. And we're going to discuss in this example exactly how we find a, b, and c. So if we have a look at the question, it says determine the nth term of the following sequence. So we start by looking at our differences. So we say 17 minus 6 is 11. 34 minus 17 is 17. 57 minus 34 is 23. We notice that that is not constant. So if that was constant, we would have a linear pattern. It's not constant. So we go again. 17 minus 11 is 6. 23 minus 17 is 6. Okay, now we see our constant second difference. And in order to work out your A, your B, and your C, you are going to do the following. This 6, your constant difference, is 2A. Then this first difference, or T2 minus T1, is 3A plus B. And then your first term is A plus B plus C. So you need to learn those three little formulas. And then we start from the bottom and we work up, because the bottom has one variable and then two variables and then three variables. So let's take a look. Show you're all very competent in this skill. We say 2A equals 6, and so A will be 3. Then 3A plus B is equal to 11, and you would sub in your value, which we have just worked out. A is 3. So B would be 11 minus 9B is 2. And then A plus B plus C must give us 6. I'm just going to get my different colors to sub in there. So we've said B we've worked out is 2. A we had worked out was 3. And so 6 minus 5C is 1. And then you just need to write out your formula. Oh, I should have put equals there. So C is equal to 1. And then we write out our formula. Tn is an squared plus bn plus c. And so that is 3n squared plus 2n plus 1. And that is how we will deal with a quadratic pattern when we are given a numerical example. So an example like this where we have all the numbers. Okay. Any questions you've got on this example from page 2? All right, again, I'm going to take no response as a positive, that you're all okay with that. There's one more example I'd like us to do on the Smart Prep notes, and you'll find this on page 4 of your notes. We're going to look at example 5 on page 4. So example 5 on page 4 is again a quadratic pattern, but this time it is when you are given a quadratic pattern with some variables. Okay, here it is. So example 5, quadratic pattern, it's got some variables in it. So let's take a look. The question says, determine the value of x in 6, 15, x 45 if that is a quadratic sequence. Now, the moment the question tells you it's a quadratic sequence, in your mind, you should immediately think about the fact that there is a constant second difference. So when the examiner says that you have a quadratic sequence, you know, all right, I stop right there, I've got a constant second difference. Which means we're going to want to work out what that second difference is. So we start off with our first differences, because that's where we would have to start. So we'd say, okay, 15 minus 6 is 9. X minus 15, well, it's not numerical, so we just say x minus 15. And then 45 minus x will be 45 minus x. So this row is our first differences. Okay, now we want to do second difference. So second difference, we do the same thing. So, okay, x minus 15 minus 9. this term minus the previous term. And we do it again over here. 45 minus x minus 15. And these ones that I've written in pink is our second difference. Now, can someone tell me what is the concept that we are going to use at this point? What are we going to use to move on and finish off this question? Yes, we're going to be doing some algebra. What concept from the number patterns are we going to have to include? My hint for you, look at what we've written in pink. Thanks, Layla. We're going to equate them, right? Because we have said, because it's a quadratic sequence, we have a constant second difference, which means this term, which is a second difference, and this term, which is a second difference, have to be equal. And so we're going to say, all right, x minus 15 minus 9 must equal 45 minus x, and I'm going to just simplify here, minus x plus 15. So I'm just distributing over there. And now, like Layla said, we are going to be doing some algebra. We are solving a linear equation. So I've got x plus 2x will be 3x. 45 plus 15 is 60. And 60 minus, what have we got there? 60 minus, plus 24 will be 84. And when we divide by 3, we get x is 28. And what I like to do at that point is just check that my pattern works. So if I write out my pattern, 6, 15, 28, so that's your x value now, 45. And we just check it. We say, okay, well, here we've added 9. 28 minus 15 is 13. 45 minus 28. 45 minus 28, I think that is 17, yes. And then our second difference every time will be 4. And you can see there is your constant second difference, which means you know that your value for x that you've calculated has to be correct. All right, are there any questions that you would like to ask about the 3 examples that we've done from the Smart Prep notes? Okay, I'm not seeing any massive shouting of hands or messages in the chat. Okay, so I'm assuming we're all happy with the 3 examples that we've done. So let's move straight over then to our question booklets. Let's move straight over to our question booklets so that we can get into our exam questions. All right, there are our question booklets. Okay, so we are starting with number patterns, which is on page 1 of your notes. Okay, I think we are probably going to get through all of these questions. That's going to be my goal for today. So let's work through them. If we get stuck on something, we can wrestle with it a little bit. But number patterns is really a part of paper 1 where you can score some really good marks. Okay, especially in grade 11, because you only have those 2 types of number patterns, your quadratic and your linear. All right, so let's get straight into it. Question 1.1 from the Eastern Cape Exemplar of 2019 says the following. Given the sequence 10, 7, 4, 1. All right, so given the sequence 10, 7, 4, 1, let's see what questions they ask us, and then we're going to start answering. So the first question asks us to write down the next 2 terms, so we're going to extend our pattern. Then we are going to determine a formula for the pattern. So let's just kind of write down our roadmap. So here we're going to be extending our pattern. Okay. Find a formula for the nth term. So in other words, that's Tn. And then which term is equal to this value? So we're going to say Tn is equal to that. So that is kind of the roadmap of what we're going to do with this question. And that would score you 7, I think, really easy marks. Okay, so let's take a look at our pattern. Let's write it on the side here so that we have lots of space to work with. So our pattern is 10, 7, 4, 1. Now, before we can answer any of those 3 questions, we need to figure out, is this linear or is this quadratic? Okay, so who'd like to tell us, is this linear or quadratic? All right, lots of linear coming through. Correct. The majority is correct in this case. Now, if it is linear, it means it needs to have a constant difference. So tell me, please type in, what is your constant difference? So I've got some 3's and some -3's that are coming in. Some are saying 3, some are saying -3. So let's take a look just to confirm how we get that. Remember, when you are finding the difference in a pattern, you always go T2 minus T1. So our difference is always T2 minus T1. So we would say 7 minus 10, which is -3. 4 minus 7 is -3. 1 minus 4 is -3. There's another thing that should have also kind of led you to believe that your constant difference is negative, and that is that your pattern is decreasing. The values are getting smaller. And so if the values are getting smaller, your D should be a negative value. All right, so if we need to now extend our pattern by 2 terms, we say, okay, 1 minus 3 will be -2. 2 minus 3 will be -5. So those would be our next 2 terms in our pattern. Okay. Next question. Determine a formula for the nth term of the sequence. Okay, so please type into your chat, what is the formula for the nth term of this sequence? Let's see, linear pattern. So no calculations required. All right, so Ty and Mamelo, they are giving us the general formula. Fantastic, either AN plus C or DN plus C. So that's a good start. Let's see what the values are going to be in our formula. Okay, we've got 3 answers that have come through and all of them are looking correct. So let's see how they got those. So first thing is, we've said our D is our constant difference. So we know our formula is definitely going to start with -3n. Now we need to do some inspection. So we say, okay, if I have -3 times 1, how am I going to get an answer of 10? Or -3 times 2, how am I going to get an answer of 7? Well, this is -3, and -3 plus 13 is 10. -6 plus 13 is 7. And therefore, our formula Tn is -3n plus 13. All right, so that is how we get our Tn for a linear pattern. Okay, third question. Which term of the sequence is equal to -179? Well, as we said when we first looked at the question, we're going to say Tn is equal to negative 179. So quickly work out for me which term is going to be the term that is negative 179. Which term will be the term that is 179 or negative 179? Okay, I've got Humaira and Kulin and Layla all coming through with the correct answer. Nice. Wyatt also getting it. Let's take a look. So we have Tn, which we've just worked out, is negative 3n plus 13 equal to negative 179. Now, something I just want to say at this point. If you had gotten the previous question wrong, so if you got the minus 3n plus 13 wrong, your teacher should then mark with continued accuracy going forward. In other words, if you had made a mistake over here and your pattern had been minus 3n plus 10, and you then made that equal to minus 179, you should get all 3 marks for the question that you are doing now. All right, so that is what we term, or we use the term continued accuracy in maths when we are marking, and that is what when we mark through with your mistake. All right, so we have negative 3n is equal to negative 192, and therefore n is 64. So the 64th term in the pattern would be equal to negative 139. All right. Questions, comments, anything you'd like me to explain again there? Okay, all good for now. Fantastic. Now, let's take a look at the next question. The next question says the following. It says, you have a linear pattern which looks like this. 3x minus 2, x plus 9, 2x plus 5. They tell you this is a linear pattern. Calculate x. This is a linear pattern. Calculate x. All right, so let's hear some ideas. How are we going to calculate x if they tell us it's a linear pattern? Let's see. How are we going to calculate x? All right, Layla is on the ball this afternoon. Kulin also coming through with that. So the concept we're going to use here is when they tell us it's a linear pattern, it means there is a constant first difference. Meaning this term minus this term, so T2 minus T1 equals this term minus this one, which is T3 minus T2. Now, you don't have to write it as I've done there in green. Next year, you're going to focus on questions like that quite a lot. But what you should be able to do is you say, okay, I know I'm going to subtract them. So I'm going to have x plus 9 minus 3x minus 2 equal to 2x plus 5 minus x plus 9. So you don't have to have that part that I've written in green, but what I've written in red, that is where you're going to score some good marks. Okay. So let's simplify. So the part about the number pattern is done. Now we're going to do algebra. Okay, so x minus 3x, that'll be negative 2x. 9 plus 2 is 11. And then on the other side, 2x minus x is x. 5 minus 9 is negative 4. So negative 3x is equal to negative 15. And so x, we get an answer of 5. X will give us a value of 5. So this question is actually quite similar to that quadratic pattern that we did from the Smart Prep notes. The only difference is because this is linear, we only look at the first differences and equate them. In example 5, because it was quadratic, we had to go to the second difference and then we could equate them. All right. Questions that you'd like to ask about 1.1b. Any questions you want to ask? Okay. No questions. Fantastic. I hope that means that you are all on the ball right now. Okay. I'd like us to now take a look at the next example. I'm just going to zoom out there so we can see both of those at the same time. Okay, so let's take a look now at the November 2011 paper from Eastern Cape. 11 years ago, you guys would have been in grade 1. That's a bit scary. Anyway, they say to you, Tn is equal to 3 times 2 to the n minus 1. So, they're giving us the formula for a pattern, and this now looks a little bit different. Okay, now, this is not a linear or a quadratic pattern. In other words, this is not one of the patterns that you currently have to know how to find the formula for. As a side note, you are going to be dealing a lot with patterns like this next year, and this is called a geometric pattern, but it's not in the grade 11 syllabus. So the questions that they ask, you are able to solve using the knowledge that you have. So let's take a look at the sort of questions that they ask us, and let's see what we can do, even though we haven't learned about geometric patterns. So let's take a look. Okay, so this is question A, part 1. Write down the first 4 terms of the sequence. Write down the first 4 terms of the sequence. Now remember, if you have the formula for a sequence, you find the terms by subbing in values for n. So if we want the first 4 terms of the sequence, we're going to substitute n with 1 and 2 and 3 and 4. And then we'll have the first 4 terms of the sequence. Okay. Now, it's only worth 2 marks. In other words, you do not have to show all of your calculations. That's what your calculator is for. Sorry, I don't know why my words are not coming out properly. Okay. So what am I going to type into the calculator? I'm going to do the following. I'm going to say 3 times 2 to the 1 minus 1. Then I'm going to type in 3 times 2 to the 2 minus 1. 3 times 2 to the 3 minus 1. 3 times 2 to the 4 minus 1. It's only for 2 marks, so I don't need to try and write down all that I've put there for you. And as we work it out, we say, okay, the first term is 3. The second term is 6. The third term is 12. The fourth term is 24. So I have now calculated my first 4 terms of my pattern. Then the question asks us, what pattern do you notice? In other words, what can you notice about what we are doing every time in this question? So let's see. It would be worth 1 mark. What pattern do you notice? Good. Deanna, Layla, both coming through with nice answers, just explaining them in 2 slightly different ways. Nice. Mamela also coming through with that. So we could either say each term is doubled to get the next term, or something else you could say is you are multiplying by 2 each time. So in this case, the question is not about the differences. We don't have a constant first difference. We don't have a constant second difference. So what are we doing every time? Well, we are doubling the term to get the next one, or we are multiplying by 2 to get the next one. Okay, and that is what we call a geometric pattern, which you will deal with quite a lot next year. The next question now says, what will the sum of the first 4 terms be? What will the sum of the first 4 terms be? It's worth 1 mark. What would you do? What's the key word in that question? Good. Mamelo, Layla, Deanna, Kulin, all coming through with that. Sum means to add. So 3 plus 6 plus 12 plus 24. And when you add those all together, the sum of the first 4 terms is 45. Okay. And then the fourth part to that question. The fourth part to the question says the following. Which term of the above sequence will be equal to 6,144? Which term in the sequence will be equal to 6,144? Any ideas that you would like to give here as to how we're going to solve this? So I don't want the answer yet. I want to know, how are we going to solve this question? Okay. Wyatt says equate the equation to 6,144. That's exactly right. Because they're saying they want the term to be equal to 6,144. And what is our term? Well, our term is 3 times 2 to the n minus 1 equal to 6,144. And that step was using your knowledge of number patterns. The rest of this question, we are now solving what type of equation? What type of equation are we going to solve here? Where is the n? Oh, there we go. Wyatt has got it. It's an exponential equation, right? Because the n is in the exponent. Okay, so when we are solving this exponential equation, actually, let me not answer this. Who would like to unmute their mic and tell us or talk us through how we are going to solve this exponential equation? Anyone brave enough to do that?
Hi, ma'am.
Yes, Tando.
So you would basically divide both sides by 3.
There we go. All right, let's just see what we get. 6,144 divided by 3. So we get 2,048.
And then you would then say 2 to the exponential of n multiplied by 2 to the exponential of -1.
Yeah.
No, but like you would, I think you would separate them.
Yeah, that's
Yes.
cool. We can do that. Let's do that. So 2 to the n times 2 to the -1.
Yeah, and then you would write 2,048.
Okay.
And then you would divide both sides by 2 to the power of -1.
Good. And just to remind everyone, remember 2 to the power of -1 is a half, right? So you're dividing by a half. Okay, and we get 4,096 over there. So what would we do now?
And then like you have to simplify 4,096 to like 2 to the power of something.
Yes. Do you know how to do that, Tando?
Not really. Not
Not
really.
really. Okay, cool. Okay, so I hope that most of you have the slightly more updated calculator than the one that I've got here. Okay, and the reason I'm saying that is on the more updated calculators, they have a button on there that's called fact, the factorizing button. And that will actually help you to factorize 2 to the power of something. Now, say you're like me, we've got a calculator that looks like this. We don't know how to do that. All that I would do is on my calculator, I would do a little bit of trial and error. So I'd say, okay, well, this is a large number. So I'd say, all right, 2 to the power of 10. And if I do 2 to the power of 10, you probably can't see that, it's very small. I get 1,024, which means we need to get a number that's bigger. So then I try, okay, well, how about 2 to the power of 12? And that works. So I get n is 12, and that would be my answer. There is a slightly different way that you could solve this. Tando, yes.
Sorry, ma'am. But how would we solve for this for n if we had the new calculator? How do you said that
Okay.
there's a button that has
so what you would do then is you type into your calculator, you would type in 4,096. So you type that in, and then you're going to push equals, and it's just going to show you 4,096. And then you're going to use the shift button. And then above one of your buttons, you're going to see that it says fact. And if you've got 4,096 equals and you then type shift fact, it will give you the answer 2 to the power of 12 like that.
Yeah.
Okay.
Thank you.
Now, there's one step here that you could do slightly differently, and I just want to show you what you could do. So at this point where we have divided by 3, you could go from this step and immediately do prime bases. So you could say this is going to be 2 to the power of 11. And therefore, n minus 1 must equal 11, and so n will equal 12. So you can see 2 slightly different methods, you get to exactly the same answer. So whichever of these 2 methods you feel more comfortable with, rather use that one. All right, thanks, Tando. Thank you for your help. Any questions that you would like to ask, grade 11s? Anything that you want me to explain again? Anything that you're uncertain of? Culin, yes. Oh, thumbs up. Okay, great. Fantastic. Any questions? Okay, I am happy to hear that. Quadratic equation, please. Okay, but this question has nothing to do with quadratics. So I just want to check, are there any questions you'd like to ask about this question, question A? Okay, nothing about question A. All right, we're going to move on to question B, and I think that's going to answer the question that Mamelo was asking. All right, so let's take a look at question B. B says the following. The number pattern 8, 20, 38, 62 is such that the sequence of second differences is a constant. Now, immediately, when they say to you, the second differences is constant, what type of pattern are they telling you you are working with? What type of pattern are you working with if they say the second differences are constant? Yes, answers coming through thick and fast. They're telling you it's a quadratic pattern. They're telling you it's a quadratic pattern. All right, so now let's see what questions they ask, and then we will answer them. Write down the 5th term of the number pattern. In other words, they're asking us, first question, to extend the pattern. We should be able to do that easily. Next, Determine an algebraic expression that represents the nth term of the number pattern. Okay, now that's a mouthful. What they are actually just asking you for is to calculate Tn, and because it's quadratic, remember that is an squared plus bn plus c. And then the third part of the question says, calculate the 20th term. In other words, they want us to calculate T20. So that is what they've asked us for at B. They've told us this is a quadratic pattern. First, give the fifth term, so we're going to extend. Next, find the nth term. So we are going to use an squared plus bn plus c, and then calculate the 20th term. So we're going to do T20. All right, so let's get straight into that and answer those questions. Okay, let's go this side, then I've got lots of space. Okay, so we are looking at B. They give us the pattern 8, 20, 38, 62. That's our pattern. Now, let's work it out. They tell us that it is quadratic, so we know we need to go to the second difference. So let's do our differences. 20 minus 8 is 12. 38 minus 20 is 18. 62 minus 38 is 24. If this was a linear pattern, that would be equal, but it's not a linear pattern, so we need to go one step further. 18 minus 12 is 6, 24 minus 18 is 6. And there we can see it's quadratic because there is a constant second difference. Now let's answer the question. The question is, what is the next term, or what is the fifth term of the sequence? So we want to find the fifth term of the sequence. So you've got to say to yourself, what would you have to add to get the next term? So I don't want you to give me the answer. I want you to tell me, what am I going to have to add to get the next term? Good. Quite a few people coming through. We're going to have to add 30, right? Because 24 plus 6 means we're going to have to add 30. So what is the fifth term going to be? If we're going to have to add 30, what is our fifth term? Yes, Layla, Kira, Mamelo, Sahara, all coming through with the correct answer. 62 plus 30 is 92. There we go, 1 mark, easy peasy. Next question. Determine an algebraic expression for the nth term. In other words, calculate Tn. And this is where we are going to use our 3 little formulas. So we know 2a must equal 6, the number in the middle, or sorry, the number right at the bottom. 3a plus b must equal our first difference, so that is 12. And then a plus b plus c, that must equal our first term, so that is 8. So let's go through our calculations. So 2a divided by 2, we'll have a. 6 divided by 2 is 3. All right, now we have a, so we are going to substitute in the value for a, and we've just worked out a is 3. So b will be 12 minus 9, which is 3. All right, so we've got a, we've got b, now we are trying to work out c, so we sub in. A is 3, b is 3. So 8 minus 6c is 2. So our formula Tn would be an squared, so 3n squared, plus bn, so that is plus 3n, plus c, so that is plus 2. an squared plus bn plus c. All right. Any questions? Anything you'd like to ask about how we find the general term or the formula for a quadratic pattern? All right, Bonati is happy. Thank you. Glad to see that. Any questions? Mamelo says, no, ma'am. Fantastic. I'm happy to hear that. All right, so let's see. The last question from this paper said, calculate the 20th term. All right, so we've got Tn is 3n squared plus 3n plus 2. They want the 20th term. In other words, n is 20. So 3 times 20 squared plus 3 times 20 plus 2. And it's been a long week, so I'm going to be lazy and use my calculator to get this answer. And the 20th term, so if we kept writing out the pattern and adding 6 and adding 6 and adding 6 to our differences every time, we would get the 20th term was 1,262. 1,262. Anything that you would like to ask about this quadratic question, quadratic pattern? Okay. I would like us to skip question 1.3 for now. We're going to come back to that one after the break because it's going to require a little bit more explanation. So I would like us to have a look at 1.4. It says Eastern Cape exemplar for 2021. So it's this one. 1.4, Eastern Cape exemplar for 2021. Okay. Given the quadratic pattern, so they are telling us it's a quadratic pattern, so they're telling us that there is a constant second difference, minus 12, minus 8, 0, 12. Firstly, determine the next 2 terms of the pattern. So I would say, well, this is asking me to extend the pattern. Determine Tn, the general term. So we're going to find the general term like we've just done in 1.2. Then, between which 2 consecutive terms does the first difference lie? We're going to look at that. They're talking about first difference. And then at D, they speak about a new pattern. All right, so we're going to go through these questions and then it's going to be time for our break. All right, so let's take a look at our pattern. Just going to write it down. So we are busy with 1.4. They give us this pattern, minus 12, minus 8, 0, 12. Okay. They tell us that this is quadratic, which means we need to find the first difference and then the second difference. So minus 8 minus 12 is 4, right? Because to go from minus 12 to minus 8, you've added 4. 0 minus negative 8, you will get 8. 12 minus 0, you will get 12. Right, so every time your constant difference is getting larger. And our second, sorry, that's our first difference, not our constant difference. So our first differences are getting larger. And then our second difference, 8 minus 4 is 4, 12 minus 8 is 4. Okay. So if we want the next 2 terms of the pattern, we want the next two terms of the pattern here, it's 4, 8, 12. So 12 plus 4, we would have to add 16. And then 16 plus 4, we would have to add 20. So 12 plus 16, next term would be 28. And then 28 plus 20 will be 48. So those are the next two terms of the pattern. So our first differences, we are adding 4 every time. So 12 plus 4 is 16. 16 plus 4 is 20. And then we would say 12 plus 16 is 28. 28 plus 20 is 48. Next question. Determine the general term. Find Tn. And remember, for a quadratic pattern, when they ask you for Tn, you are going to look at your three little equations. So the first one is 2a is equal to 4, our second difference. 3a plus b is going to equal this very first difference. And then a plus b plus c must equal our first term, and that is minus 12. And as we've just practiced, let's do our baby algebra here. So a is 2. So 3 times something plus b is going to equal 4. And we've worked out a is 2. So we say, well, 4 minus 6, that is negative 2. Then a plus b plus c, let's just, there we go, get some space, equals negative 12. And we've worked out b is negative 2. We worked out a is positive 2. So minus 12, and this becomes 0, c is minus 12. So let's write down our formula. Tn is an squared plus bn plus c. And so 2n squared minus 2n minus 12. Okay. Now they bring in a new concept. The new concept says, between which two terms does the first difference of 192 lie? So they're asking, where will the first difference equal to 192? Now, this is actually quite a common question. You are going to see, the more past papers you work through before your exams, that there is a very big link between a quadratic pattern and a linear pattern. And the link between a quadratic pattern and a linear pattern is, if you look at a quadratic pattern, the first differences will always make a linear pattern. Okay, and this is something that is going to be asked a lot of you next year in grade 12 as well. That link between a quadratic pattern and a linear pattern. And the link is, if you look here, there is our quadratic pattern. I've written it in red. And then there is our linear pattern, the first differences, which I've written in green. So when the question asks for first differences, look at your first differences. Because you will notice that your first differences, they make a linear pattern. Our first differences make a linear pattern. Now we've discussed already, how do you find the equation for a linear pattern? Well, it's dn plus c. So let's look at our linear pattern. Who thinks they can tell us, how will we find the formula for this linear pattern for our first differences? Anyone willing to unmute and explain how they think we'll be able to do this?
We could perhaps use the second as the first difference for the pattern.
Perfect. So if we have a look at our linear pattern, our difference every time, as Benanti said, our difference every time is 4. Any ideas? What is the C value going to be for this linear pattern?
0, ma'am?
Correct. It's going to be 0. And if you want to check it, remember we would say, okay, it's going to be 4 times 1. I must get an answer, in this case, 4. 4 times 2, I must get an answer of 8. 4 times 3, I must get an answer of 12. And in the previous questions, we had to put a value in this position to get our answer. But for this question, 4 is equal to 4, 8 is equal to 8. So our C value is actually 0. Now you don't have to write that down because we don't normally say 4n plus 0. So our pattern is just 4n. Now remember, they've said to us, we want our first difference to equal 192. So Benanti, can you tell us, what are we going to do from here?
We would then replace Tn with the value of 192 because that's the value of the term.
Very good.
And
so
then
we're going to have 4n equals 192.
Then we divide by 4, and then we would have 48 as the answer.
Okay, so we get n is 48. And if you got to that point, you would now have 2 out of 3 marks. You would now have 2 out of 3 marks. And the reason is, the question says, between which 2 terms is the first difference 192? Between which 2 terms is the first difference 192? Okay. Now, the way you're going to get this is we are almost at the final answer, right? We just need 1 more mark to answer that final question. So if you look back at our original pattern, I'm going to just put a little box around it so we focus on, that's where we are. Okay. How did we get this 4? How did we get this 4? We said T2 minus T1, that gave us 4. How do we get 8? Well, to get the 8, we said T3 minus T2. That gave us 8. And how did we get the 12? Well, we said T4 minus T3. So the first term of our differences was actually between T2 and T1. The second term was between T3 and T2. The third term was between T4 and T3. So, can anyone answer between which 2 terms is the first difference going to be 192? Okay, and I see Layla has got it. And I want to just show the rest of you how we're going to get it. So the answer is between T48 and T49. Right, now here we've got the 48. That was our answer that we got. We got n was 48. So I want to just remind you, we said T2 minus T1 was equal to 4. T3 minus T2 was equal to 8. T4 minus T3 was equal to 12. And this was from our quadratic pattern. But which term in our linear pattern, let's use a different color here, which term in our linear pattern was 4? In our linear pattern, 4 was the first term. in our linear pattern, 8 was the second term. And in the linear pattern, 12 was the third term. So if you then have a look at this pattern and we work out, okay, well, we want n to be 48. Well, we'd say, okay, sorry, not n, 192. Sorry, that was just a door closing. Behind me. All right, so 192 is our answer here, and we've worked out 192 is the 48th term. So if we have a look at our pattern here, T1 is T2 minus T1. T2 is T3 minus T2, and T3 is T4 minus T3. And so T48 would be T49 minus T48. Okay, so this requires some deeper understanding. It requires that understanding of the link between your quadratic and your linear pattern. Okay, so we got to this point of question C. And now let's have a look at question D, because this question is asked in a bit of a different way. It's not a difficult question, but it's asked a little bit differently. It says a new pattern Pn is formed, and Pn is Tn minus 168. In other words, they're saying to us, take your old pattern and subtract 168 from each of the terms. Okay, so let's just write down our pattern. So we've got it right here. So we worked out Tn was 2n squared minus 2n minus 12. And they're now saying to us, we're taking this pattern, but we're going to subtract 168 from every single term in the pattern. So it means that Pn is 2n squared minus 2n minus 12 minus 168. Or if we simplify it, Pn is 2n squared minus 2n minus 180. So that is our new pattern. The question now says, determine the number of negative terms in the new pattern. Determine the number of negative terms in the new pattern. So what is a little bit different is often they would say something like this. Which term in Pn is the first negative term? That's kind of the way that you've probably seen them asking this question in the past. So if they had said to us, which term in Pn is the first negative term, you would have said Pn must be less than 0 because it's the first negative term. Well, we are going to do a similar thing here because we want to know how many negative terms are there going to be in this pattern. So we're going to say, all right, let's make Pn less than 0. So 2n squared minus 2n minus 180 must be less than 0. All right, before I try and factorize, I'm definitely going to divide by 2. I'm going to divide by 2 like that. Okay. Now, factors of 90 that will give me -2. I don't know my factors of 90 very well, but I can't quickly find factors of 90 that will give me -2. And so the easiest thing to do, or the best thing to do, is to then use the quadratic formula. However, the quadratic formula is when you solve a quadratic equation. So let's tell the marker, we're going to say n squared minus 2n minus 90. Let's make it equal to 0. Because if it's equal to 0, we can use the quadratic formula. All right, Tando, you have a question. Please ask the question before we move on.
Hi,
Hmm.
why didn't you divide two? You divided everything by 2, right?
Yes.
So then you had to divide 2n by 2.
Thank you. Yes, you have found a mistake there. Yes, we should divide everything by 2. So that should, there we go. Thank you. Perfect.
No problem.
Good. All right, so now we're going to use our quadratic formula. So we know n is minus b plus minus the root of b squared minus 4ac all over 2a. Hey, you've used that enough in the last year. Hopefully you know that formula well. All right, so let's sub in. We've got minus negative 1, so that's our b value, plus minus negative 1 squared minus 4 times 1 times negative 90, all under that square root, over 2 times 1. Let's just, there we go. Then you can all see that. All right, calculator is going to be our friend here. So 1 plus our root. And I get either n equals 10. Now I feel silly because now that we divided it there, it's actually very easy to get the answer. So I think you all would have been able to factorize this fairly easily. So you could do what we've done here, or hopefully, because we can see now that that 2 wasn't there, we'd say, what factors of 90 will give you negative 1? What factors of 90 would give us negative 1? Well, it would be negative 10 and positive 9. Minus 10 times 9 is minus 90. So we have 2 different ways of actually getting to the same result. Okay. Because either one of those, whether you've done what we've got in orange, or you've done what I've drawn over here, either way, we are going to have to draw a little sketch. And the reason is we are solving a quadratic inequality. And when you solve a quadratic inequality, you need to draw a sketch. Okay, I know that some schools, you don't necessarily draw a sketch like this. You use the table of signs. Where is it positive? Where is it negative? That's also fine. So what have we worked out? Well, we've worked out that the one value here is at negative 9, and the one value there is at 10. And we are looking where the values are less than 0. So we're looking over here. We're looking at all the values underneath our parabola, underneath the x-axis. So where our parabola is negative. And remember the question said, how many negative terms are in this pattern? So let's see, anyone? How many negative terms have we got in our pattern? Because up to this point, we've been doing a whole lot of algebra. But now you have to understand something about patterns to get the correct answer right at the end. Okay, Benati has sent me a message, so has Deanna, and they've both gotten it right. Let's give it another second and see if someone else is going to come through. Tando, close, you're out by 1. Mamelo, close, you've got a sign that's wrong. Tando is still out by 1. Ethan, you've got it. Okay, sorry, Ethan. Let's have a look. Now, what quite a few of you have gotten right is you understand the concept that for a number pattern, the n values have to be bigger than 0, right? So we actually are forgetting about this whole side of our graph because we can't have the -1 term or the -10 term. We are only looking at the values of n that are natural numbers. Okay, so we are only looking on this side, on the right-hand side. So the first natural number would be when n is 1, and then 2, and then 3, and then 4, and it's going to continue. And then things just get a little bit confusing here at the end. And that's why some of you are getting the right answer and some of you are getting just 1 off. So we've worked out here, it's definitely going to be between or bigger than 0 up to this point. But have a look here at your inequality. You are looking at values that are less than 0. And if you look at this specific point here, the 10th term is not less than 0. At the 10th term, Pn will be equal to 0. And so we can't use this. And that's why the answer is there are 9 negative terms. If your answer was going to be 10, if they had said Pn must be less than or equal to 0, then you would say there would be 10 terms. But because it's just Pn less than 0, we can't include this 10th term. So we're going to go from 1 up to 9. We're going to go from 1 up to 9. Okay. Definitely a different question. I must say, when I saw this for the first time, I thought, oh, this is nice. It's something different. It's testing some deeper understanding that you've got of the concept. And this brought in your quadratic inequality concepts as well, not just number patterns. Okay. Are we ready to do E? The last part of this question. So E says the following. Show that, well, prove or show that Tn, prove or show that Tn is always even. Okay, so let's write down Tn. We worked out the pattern. Tn is 2n squared minus 2n minus, what was it at the beginning? 12. So any ideas? How are we going to prove that Tn is always going to be an even number? How would we prove that Tn is going to be an even number? And this is not a difficult question, okay? But again, it requires a little bit of thinking. So it's not impossible, but you do have to think a little bit differently. Okay, so why is Tn always be positive? Oh, sorry, not positive. Why would it always be even? Okay, so I've got 2 messages that have come through, and both of you have suggested we do substitution. Now, this is something I teach boys, so I'm going to say my boys always make this, well, not always, they often make this mistake. When a question says prove that or show that, I want you to make a note. Substitution is not a valid proof. Substitution is not a valid proof. And the reason I say this is, if you're subbing in, and both Bonanti and Layla suggested we sub in a positive, an even value, we sub in an odd value, and if we're always getting an even answer, then the answer is always even. The issue is, they ask you to prove that it is always even. Now, if you are going to substitute and you want to prove that it is always even, you are going to have to substitute n as 1 and 2 and 3 and 4 and 5 and continue for infinity. Which, I mean, it's not really the best approach, right? You don't really want to have to keep substituting in and substituting in and substituting in. All right, so let's think about a different way. So let's think about the fact that what makes a number even? Let's hear. What makes a number even? What makes a number even? All right, someone said an even number has no remainder. Okay, someone else has said an even number has more than 2 factors. And then Wyatt and Miriam have come through with the correct answer. An even number, just think back to primary school. An even number is a number that you can divide by 2. That's an even number. It's not a complicated thing. An even number is a number that you can divide by 2. So how can I, in a very simple way, show that this number is even? Right, I'm trying to lead you to the answer. I don't want to give it to you. So how could we show that this number can be divided by 2? Okay, so Miriam and Benati both saying, let's divide the formula by 2. Now you're definitely on the right track, but if I divide my formula by 2, tell me what is going to be on this side? What is going to be on our left-hand side if we divide the equation by 2? Technically, if you are dividing this whole thing by 2, then this is going to be Tn over 2. But you two are definitely on the right track. So we are going to divide by 2. Yes, Deanna, finally, you've come through with it. We're going to take out the common factor. What is our common factor here? Let's see. What is our common factor? Yay, finally, so many answers coming through. Okay, our common factor is 2. N squared minus n minus 6. So if there is a common factor of 2, then it has to be an even number. Done. 2 marks. If there is a common factor of 2, then the number would have to be even. And that would get you your 2 marks. Okay. But I think we kind of gained something quite important from doing this question E, is substituting in is not going to give you a proof for something always being even or always being positive. You have to try and find a way of proving all cases. And by taking out 2 as a common factor, we are proving that for all cases, it doesn't matter what is inside this bracket, it will be an even number. Okay. Any questions that you would like to ask about 1.4? Okay, yes, Miriam's got a nice question. How would you prove that something is always positive? Okay. How would you prove that something is always positive? Okay, so the key when you want something to always be positive is, let's think about it this way. What do you know, what kind of algebraic concept do you know will always be positive? And it's actually something that I noticed, I'm just scrolling through, Humaira actually wrote it down earlier. Okay, how do you, what do you know is something that will always be positive? And guys, I know that you know this. Ah, Rutendo, thank you. A square, something squared is always positive. Doesn't matter what is in that bracket, it's always positive. So if you want to prove that something is always positive, you want to have it as a value squared. And then, so that could be your full answer. Or if you have something squared plus a positive number, then it will also still be a positive. Okay, so to prove that something is always positive, it would be something like, prove that, now let's hope that I do this correctly, prove that n squared minus 4n plus 4 is always positive. Prove that Tn equals n squared minus 4n plus 4 is always positive. Okay, now remember we said if we want to prove that something is always positive, we want to write it as something squared. Now, can you write n squared minus 4n plus 4 as something that is squared? Can we write that as something that is squared? Let's see, come on, you can do it. Nice, Tamara, yes you can. Rutendo also getting it. If you factorize this, it will be n minus 2, n minus 2. And what's the short way of writing that? N minus 2 squared. In other words, this quadratic number pattern would always be positive because we can write it as a value that is squared. Okay, Miriam, I hope that answered the question that you had at that point. What about the plus 4? That's what I've been asked. Okay, well, so if we're factorizing, let's just get it over here. So if you are factorizing n squared minus 4n plus 4, remember what you will say is you'll say n squared is n times n. What factors of 4 give you negative 4? Well, it's negative 2 times negative 2 gives you a positive 4. And if you multiply this out, you'll get back to that position. So the positive 4 has been included when we did our factorizing. Okay. Now, let's take a look at that question 1.3 that we left out. Let's take a look at that question. Wait, actually, I'm going to change my mind. Right? They say that that's a woman's prerogative to be able to change their mind. So I'm going to do that. Okay, we're going to go to question 1.5. Let's go to question 1.5. And if we have time, we'll go back to that question 1.3. Okay, because there's something very nice in this question 1.5 that I'd like us to discuss. Okay. Question 1.5. Given the sequence, -3, 1, 5. Okay. Write down the fifth term, determine the general term, and show that 394 is not a term. All right, so let's just think about what they're asking us here. Firstly, write down the fifth term. They're telling us to extend our pattern. So that's the first instruction. Determine the general term. So they're asking us to find Tn. And then show that 394 is not a term in the sequence. We are going to say, okay, Tn equals 394, and then we're going to see what happens. Okay, so we're going to extend our pattern, we're going to find the general term, and we're going to make Tn equal to 394. All right, before we can answer those questions, tell me, what type of pattern are we dealing with? -3, 1, 5. What type of pattern? Okay, I've got only 2 answers that have come through. Okay, there's 3, 4, 5 coming through. It is definitely a linear pattern. Most definitely a linear pattern. And let's take a look at how we are going to work with this linear pattern. Okay, so 1.5a, let me just write out the pattern, minus 3, 1, 5. Okay, a nice easy linear pattern because our constant difference every time is 4. Our constant difference every time is 4. We are adding 4 every time. Okay, so when they ask you, write down the 5th term of the sequence, the first thing you would do is you'd say, okay, 5 plus 4 is 9. And then 9 plus 4 is 13. So when they ask you, give the 5th term of the sequence, then T5 is 13. All right, so why is it linear? It is linear because there is a constant first difference. That is why it is linear, a constant first difference. All right, then determine the general term of the sequence. In other words, we've said it's linear, so we're going to do dn plus c. Okay, so I want you to quick work out what is the formula for the general term of that sequence. And you can use inspection, so let's see what answer you get. All right, I've got 3 answers that have come through so far, 4 answers that have come through so far. All of you are getting at least 1 out of 2. One of you is only going to get 1 out of 2. The others are going to get 2 out of 2. All right, so let's have a look. All of you got the fact that the difference is 4. So it's going to start with 4n. Now remember, you need to use inspection. So you say to yourself, okay, if I said 4 times 1, I want my first term to have an answer of -3. If I say 4 times 2, my second term should have an answer of 1. And if I said 4 times 3, my third term should have an answer of 5. So what would we do? Well, we say, how do I get from 4 to -3? I subtract 7. How do I get from 8 to 1? I subtract 7. How do I get from 12 to 5? I subtract 7. And so my formula is 4n minus 7. Well done to everyone who got that right. Okay. Third question. And this one was the slightly different one. It says, show that 394 is not a term in the sequence. In other words, Tn, let's make it equal to 394. And let's see what happens. So remember, we would use what we call continuous accuracy. So whatever your answer was in part 2, we take it through to the third part. So we say 4n minus 7 would equal 394. So 4n would equal to 401. And if we say 401 divided by 4, we get 100,25. Now tell me, why is 394 not a term in the sequence? Why is 394 not a term in the sequence? Benati has sent a good one. Mamelo has said it has a decimal. Wyatt has said it's not a whole. Amara has said it is a decimal. So right, I think you all understand the concept. N must be a natural number to be a term in the sequence. or in the pattern. And natural numbers is 1, 2, 3, 4, 5, and so on. So they are positive integers. And this is not a natural number. It's not a positive integer. Therefore, 394 is not a term in our pattern. Okay, so the important concept, don't use the word decimal because, I mean, if you got the answer n equals 100, you can write comma 0, 0. That's a decimal. So it's not the decimal that's a problem. The problem is that it is not a natural number. Okay, so the problem is it's not a natural number, and that is the reason why that term is not in the pattern. So it's not because it's a decimal, it's because it's not a natural number. Okay, so that was question 1.5a, a nice linear pattern. Let's have a look then at B. The quadratic sequence. So immediately they're telling you that this is a quadratic sequence. 0, 5, 12 has the general term Tn equals n squared plus 2n plus c. N squared plus 2n plus c. Show that c equals -3. Okay, so we are going to do this by substitution. Okay. Calculate the 10th term of the sequence. So that's T10. And then they say, which term in the sequence has a value greater than 360? So we're going to say, we're going to say Tn is bigger than 360. All right. So let's answer our question. Let's answer our question. So we are looking at 1.5b. They give us this pattern, 0, 5, 12. They tell us this has a formula, Tn equals n squared plus 2n plus c. Now there would be two different ways you could use in order to solve for c. Let's hear from you. I'd like to hear from you. What do you think we are going to do? Because we have two methods we could use to work out C. Guys, don't give up now. We just have 15 minutes left. All right, Layla says you have A and B. So you can say A plus B plus C equals 0. Good. Deanna says use the formula to find the variables. Fantastic. So remember, we said when we do a quadratic pattern, we have our three little calculations. We say 2a equals the second difference, 3a plus b equals T2 minus T1. And our last little formula is A plus B plus C equals the first term. Now, if you have a look at the formula that they've given you here, remember your A is your term in front of your n squared, so A is 1. Your B is the value in front of n, so that's 2. Plus C equals, and like Deanna has said, we're going to use 0 because remember that is our first term. And there we get the answer that they wanted. C is -3. So that's the first way you could use in order to find C. The other way you could use to find C is you say, okay, well, here's my formula. Tn squared is, or Tn is n squared plus 2n plus c. And you could then sub in one of your points. My first term. So what is my first term? My first term is 0. So 1 squared plus 2 times 1 plus c, and so c is -3. Or you could have said my second term. So my second term is 5. 2 squared plus 2 times 2, and again, you would get c is -3. So a few different methods you can use in order to find that missing part of our formula. Questions there, please ask. Ask if you've got any questions. Right. Nothing coming up straight away. So let's have a look at the second part of the question. It then says, calculate the 10th term of the sequence. So T10. So 10 squared plus 2 times 10. And we've just worked out this is -3. So 100 plus 20 is 120, minus 3 is 117. Yay, do it without the calculator. Obviously, you've got your calculator with you, so use it if you feel that you need to. And then they say to us, which term has a value greater than 360? So Tn must be bigger than 360. Again, this is where our continued accuracy or progressive marking will come in. So we're going to say n squared plus 2n minus 3 must be bigger than 360. So n squared plus 2n minus 363 must be bigger than 0. All right, we now need to factorize that. Let's see if I can get an answer fast enough. No, let's try one more. No, I'm not getting the answer as fast as I hoped that I could. So if you can't factorize it within a few seconds, it's always better to use the quadratic formula. All right, so we're going to say n squared plus 2n minus 363. Let's make it equal to 0. And the reason we make it equal to 0 is the quadratic formula is for a quadratic equation. It is not for a quadratic inequality. Okay, so n equals minus b, so that's minus 2, plus minus 2 squared, minus 4 times 1 times minus 363, all under that big square root, over 2 times 1. And we now, again, let our calculator do all the heavy lifting. There's no way I would want to try and do that by myself. Also, I probably couldn't because we get a, nice proper decimal number here as our answer. So we get either n is 18,08, or if we do it where there's a minus in front of the square root, n is negative 20,08. So we have used our quadratic formula to find the intercept of our parabola. So if we think of our parabola, we've said, okay, this one intercept over there is at negative 20,08. Our other intercept over there is at 18,08. And we now need to, actually, before I explain what we're going to do, who thinks they can tell us what the answer is? What is the answer to our question? Which term has a value greater than 360? All right, Benati has come through with the correct answer. My hint is you don't have to do any more calculations at this point. Okay, so Benati has gotten the answer. Yes, Wyatt, you've got a 2. Deanna, close. Close, but not quite. Okay. So let's look at what they said. They said to us, we want this value to be bigger than 0. So if you look at this parabola, bigger than 0 would be those two parts, right? But we know, and we've said this, that n can't be negative. So we can't look at this part, right? Because we know n is not allowed to be a negative value. So we're looking on this side. So tell me, 18,08, that is not, remember we said n must be a natural number. So that is not a natural number. So you say, okay, well, we're looking on the right-hand side. So that's where the numbers are getting bigger. So what is the first number bigger than 18,08? The first number bigger than 18,08 is 19. There we go. First number bigger than 18,08 is 19. Okay. At this point, before we answer that last question with the handshakes, because it's a very interesting question, I want you to think about this. If we had a quadratic pattern, n squared equals, or Tn equals n squared minus 4n plus 2 plus 4. N squared minus 4n plus 4. And I say to you, what is the minimum value of this pattern? What is the minimum value of this pattern? Okay. It's a concept that I think you're all aware of it, but it's always good to be reminded of it. This is a quadratic pattern, and a quadratic pattern relates to which type of graph? A quadratic pattern will always give you which type of function if you were to draw it. It always gives you a parabola, right? Because it's an n squared, right? It's an n squared, so it would look like a parabola, which is an x squared. So if we think of this pattern, n squared minus 4n plus 4, let's just draw its basic shape. Will this be a happy face or sad face parabola? Happy face, right? And the reason is our a value in front there is positive. So because this is a happy face or a positive parabola, where would you find the minimum? Where would you find the minimum of a happy face parabola? Ah, yes, I see Layla and Miriam. It's here at your turning point. Now you've got two methods you can use to find the turning point. To find the turning point, you can either use completing the square, which I really don't recommend. If you love it, then please go for it. Or much easier is the axis of symmetry, which is x is minus b over 2a. At my school, we show the completing the square and we say, don't use this until we need it in matric. We focus on x is minus b over 2a because I think it is much easier to work with. All right, so let's fill in. So minus, our b value is -4. Our a value is 1. So 4 divided by 2, we have a minimum when x is 2, or actually what if we worked out, it's when n is 2, right? Because our formula is when n is our variable, not x. And so what would our minimum be? Our minimum, let me just use a different color here. Our minimum would be T2. So 2 squared minus 4 times 2 plus 4. So that's 4 plus 4 is 8. minus 8, the minimum value of this pattern would be a 0. The minimum of this pattern would be a 0. So this is often how we then bring in functions, in other words, the parabola, with our quadratic number patterns. So if you have a Tn which has a positive n squared, it would look like this, and it would have a minimum. If you had a Tn that was a negative n squared, it would look like this, and in that case, it would have a maximum. But regardless of whether it has a minimum or a maximum, you would always use the turning point, because that is where we find the minimum or the maximum. Okay. Any questions about this kind of additional example that I've given you? Because I think it's quite important. I obviously don't know what your final exam is going to look like, but this is something that has come up, and it comes up even in the matric papers as well. So it is something important. All right, a linear, so Wyatt is asking, what about a linear pattern? They won't ask you for a minimum or maximum of a linear pattern. And the reason for that is a linear pattern is a straight line. So it's a line that looks like that, or a line that looks like that. So it goes to negative infinity and it goes to positive infinity. So it doesn't have a minimum or a maximum value. Okay. All right, last question that I would like us to discuss. We're going to go over by about 5 minutes. So if you really have to dash off, you can do so. Miriam is asking what other topics could be integrated into number patterns. The main topics that would be integrated into number patterns would be the parabola, like we've done now, or it would be a quadratic equation or quadratic inequality, like we've done here. So we've done lots of quadratic inequalities today, and then also it would be the quadratic function, which is your parabola. Okay, so let's take a look at this handshake problem. I love this question because it's so different. It's something really different, but it tests some good understanding. All right. The table below represents the total number of handshakes exchanged between random people. Each person shakes the hand of another person only once. So if I've shaken hands with Miriam, I'm not going to shake hands with her again. If Miriam has shaken hands with Wyatt, not going to shake hands again. And they give us this table. They say, if there are 2 people, there is going to be 1 handshake. Now, what I like to do is I want to try and visualize this. So if I've got 2 people, there's going to be 1 handshake. There it is. There's the 1 handshake. If I have 3 people, they say there are going to be 3 handshakes. And that makes sense because they can shake hands there, they can shake hands there, they can shake hands there. Now, let's draw 4 people. They haven't given it to us, but let's see. Okay, 4 people. Who has an idea? How many handshakes would there be between 4 people? Any answers that will come through? Okay, I'm saying 4 handshakes.
Wait, ma'am, so do they not like, since like, let's say the one in the top left corner, right? Wouldn't it shake hands with each person?
Yes. So person over here can shake hands there and there and there. So 4 is definitely too little.
So would it be 12?
12 is too much. Okay, so let's see. This person has shaken hands there and there and there. Let's move to the bottom left person. So this person has already shaken hands with the person above them, but they can shake hands over here and they can shake hands over there. Now we can look at the
Oh,
person
my
at the
bad.
bottom. Now we look at the person at the bottom, right? They've already shaken hands to the left. They've already shaken hands up to the left, and they can shake hands over here. Is there any handshake at this point that has not taken place? Is there any handshake at that point that has not taken place?
No.
Good. Nice, Mishka. We have now every single person has shaken hands. So over here, we had one handshake. Over here, we had 3 handshakes. And over here, we have 6 handshakes. The people that have shaken, let's say, in the circle, and then these 2 would have to cross over to make sure that they've shaken hands there. Now, we could keep drawing these pictures forever, but we want to try and find a pattern. However, normally when we look at patterns, we don't start with there being 2 people or 2 terms. We start with 1 term. So let's have a look there. If you have 1 person, how many handshakes will there be?
0.
0. Good. Now, at this point, you should hopefully start seeing a pattern. What type of pattern is this?
Is it linear?
Not linear.
Because I mean, it's just like 1, 2, 3.
Remember your differences are 1, 2, 3. But if it was linear, then this would have to be constant, right? So what type of pattern is it? It is quadratic because the second difference is constant. So it's a quadratic pattern because our second difference is constant. So when they ask us, what is the value of A over here? They're asking you, give the 5th term. Give the 5th term. So what is our answer going to be for A? What will the 5th term be in our pattern? 0, 1, 3, 6. So here we would add 4, and 6 plus 4 is 10. So I'm not going to draw it, but if I was to draw 1, 2, 3, 4, 5, and I want to do all the connections, there would be 10 connections for those people shaking hands. Now the question says, what is the value of B? What is the value of B? In other words, they're asking you to calculate T100, right? The 100th term, when there are now 100 people, how many handshakes will there be? So without stating the obvious, there will be a lot of handshakes, right? So quadratic pattern, we know how to work out the formula. 2A must equal that first one at the bottom. 3A plus B must equal this one over there. And A plus B plus C must equal our first term. So A is a half. 3 times a half plus B is 1. So this is 1 minus 1.5, so that is negative a half. And then half minus a half plus C equals 0. So C is 0. In other words, Tn is a half n squared minus a half n. And so in order to work out T100, in other words, when there are 100 people shaking hands, We substitute n as 100. And we get, if there are 100 people in a room and everyone must shake hands with everyone else just once, we will have just under 5,000 handshakes that will take place. So this question C, this handshake question, I don't think it's a very difficult question. However, it does take a lot to get to the point where you realize, okay, this is just a quadratic pattern. Okay. And sometimes with number patterns, that's what makes it tricky, is it takes a little bit of insight before you can solve that problem.